All right, for this, we're going to take a look at a couple of PHET animations. These are actually pretty good. They're simple. They certainly will need a little bit of instruction over the top of them, but they are neat. We'll start by looking at this black body spectrum tutorial where it explains black body radiation. You notice here there's a lot of information. If you down-click, there's an overview for the teacher with some PDFs. There's some related simulations as well as translations, so that there's a lot of good stuff in here. So if we click on it, you can also download them if you don't have access to the internet. But here it shows sort of what a black body would look like. So it's something like our good old sun, shown off on the far right here. Our sun would have most of its light or its peak in terms of what it's giving us in the visible spectrum with a little bit across. You can actually see the labels here. There's the visible, ultraviolet, and infrared. As our object gets brighter, we still see most of it in the visible, but there's more in the others. We have the graph value here where we can move this along and talk about the actual wavelength of the different object and the amplitude. So all that is good. We can change the intensity or the brightness of it, and then we can also bring the object down to things that are much, much dimmer than the sun. So this is good. I think it explains black body radiation and gives you an idea of how we would see sort of a distribution there. I do think this is helpful. I do think, again, it's going to need a lot of help from the instructor to deliver this content. So it's absolutely a supplement. This would be a hard thing to do in a distance learning environment unless you had a nice worksheet to go with it. The second one here, we'll take a look at one more that I actually really like. I think sometimes when we're modeling atoms and molecules, we have a lot of challenges because of size. And diffusion is something I always find myself drawing dots on the board and talking about where they would move. But this is one you could maybe demonstrate in front of your class. So we'll go ahead and we'll crank up the number of particles on one side of our container. And on the other side of the container, let's crank it up to an even larger number. And we'll get the data here. So right now we have 50 blue balls on one side. And let's make that a little more than 70. Now we have 90 on the other side. And so once we have it here, we can remove the divider and see what kind of movement we get. And with the divider removed, we obviously see movement both directions, but a majority of the movement from the red to the blue. So this is good. You can see the numbers. The kids could plot this. You could talk about this. We could pause this scenario and talk about how the movement's going one way versus another. There's all of these variables that we can mess with, which I think is really neat. So let's say we did a different scenario where we were here, but they were larger on this side. Something I often talk to my astronomy students about is how, how some objects like hydrogen and helium at the same temperature will move a lot faster, even at the same temperature, because they have more inertia, or less inertia, sorry, and so they go out of our atmosphere. So this is be a lot of fun. Remove the divider, and we see here that most of our movement is the smaller particles to the other side. We can look at our data and play with that. So there's so many variables here that you can mess with. I really like this as a potential interactive tool for the kids to start looking at diffusion and the factors that affect it. This is something I could absolutely see using in class, and I very much like it.